Hello everybody. In this video we're going to look at the sum rule in differentiation. In order to understand it, let's assume we have a problem here. We have a big bucket of water in which we can pour the water from either tap A or tap B. And let's also assume that these two taps, they're different. One can pour water in it at the rate of 6 cubic feet per second, and tap B can pour in water at the rate of 3 cubic feet per second. And let's also assume that initially there is 2 cubic feet of water already in this tub. So the question we're trying to answer here is, at what rate does the volume of water change inside this tub? So in order to do this, we can either do it physically and measure it, or we can do it mathematically. Mathematically, in order to do this, we'll have to write some equations, or we have what we call writing a model for this problem. So as you can see, imagine tap B is shut and we only have tap A turned on. And since it pours water at the rate of 6 cubic feet per second, the amount of water that it will pour in, say, t seconds is 6 times t. 6 being the amount per second times the number of seconds, which is t. Similarly, assume that tap A is off and only tap B is on. In that case, the water is poured into it at the rate of 3 cubic feet per second, so the amount of water will be 3 times t. Looking at this problem, if we just had tap A on and poured the water, the total amount of water at any point will be 6t plus the initial amount. Similarly, if only tap B was on, we will have 3t plus 2. But what happens when both taps are on? There will be an initial amount, which is just 2, the amount the tap A supplies, which is 6t, and the amount that tap B supplies, which is 3t. So, in other words, the total amount of water in this, assuming both taps are supplying, is 9t plus 2. Recall, we have the problem of finding at what rate is the volume changing. Now, assuming if only tap A was working, then the rate at which water will be changing, at which the amount of water will be changing, is the derivative of this function, which is dependent on time, obviously. So d by dt of VA gives us the rate of change of volume due to tap A only, and that comes equal to 6. We know that from the basic simple rule of differentiation. In the same way, if only tap B was operating and A was totally shut, the water would have been 3t plus 2, total amount. But the rate of change of water would be simply d by dt of VB, which is 3. Notice in both of these cases, the initial amount of water does not change the rate at which volume is changing. The volume strictly changes in this tub when water is poured, and that depends strictly on at what rate it is being put inside it. Here we have the same two expressions for VA and VB and their rate of change, and we have calculated the total amount of water in the tub, which is amount due to tap A, amount due to tap B, plus the initial amount, which is 6t plus 3t plus 2, and then we calculated the rate of change for that total volume, which again comes out equal to 9. So what do we see here? We see the rate of change of total volume, which is 9, is equal to the rate of change of volume due to just tap A, plus rate of change of volume due to just tap B. So although I showed you the derivative of the sum of two functions, in this case there are two functions that make V, capital V, are VA and VB. So what I showed you, the rate of change of this capital V is equal to the rate of change of this v sub a, that's the one function, and then rate of change of v sub b, which is the second function. So the total derivative is the sum of these derivatives of each individual function. And I showed you this in the case of a special case when the volume is a simple linear function of t. In general, this process will work, and this rule will always work. The derivative of sum of a number of functions is equal to the sum of their individual derivatives, which is what's called the sum rule in differentiation.